and I'm gonna kind of get at it. So the first thing to do would be to go to GitHub. Go to Solana Labs. Now, Dexterity was published as open source. A big part of the project that we are working of is identical. So the interface and everything, as you see, are identical. There's some things that are still closed source, like our risk engine and a couple of other sort of more enterprise features that we've been working on that we're going to talk about later. The plan is that anything that's in the public sphere, even if we find bugs or we want to make features publicly available, they will kind of be contributed back, and we have been contributing little fixes already. But there's some things that in the mean, for the time being, are going to be closed source, and then we kind of decide as a community where we go in the future. So I'm just going to start by cloning this. So I'm going to go into my, can everybody see that? Yeah. I'm going to go into my projects folder, and I'm going to git clone, and I'm going to call it Dexterity work. So, okay. So the next thing I'm going to do is I'm going to fire up my Python. And here's one I was working on earlier, but I am going to start fresh. Here we are. Trusted. I'm going to do a new window. Okay, so just to sort of quickly go through the structure here, there isn't anything too surprising. Programs is the selection of the programs. Now, there is a reference or a couple of references, for instance, in here. These are not the ones that the Hxro network deployment actually uses. The other kind of important programs here are, well, we use the AAOB as a sub module, so it's not actually in there. The Dex itself, which is kind of the giant calculator that keeps track of all the cash flows, all the funding, all the deposits, and then kind of talks to the risk engine to find out what's allowed to be done at any one time. The dummy oracle is a testing facility for prices. Fees is a fairly simple kind of plugin where you can plug in a fee model. We use constant fees at the moment, so maker taker. And instruments is how you plug in new instruments. So the default instruments contract, if you like, implements the perp, futures, and options, but there's nothing stopping you from writing your own and bringing them into the ecosystem. Okay, so just a couple of sort of housekeeping steps. Okay, so I guess important, the Dexterity SDK is, I guess, the Rust SDK, and then the client folder is the Python SDK, and I'll talk a little bit more about how that's been created, because there's a lot of community work behind it. It's also kind of very interesting piece. I'm just gonna mark this as source so I get good auto completion, and then what I'm gonna do is open a terminal. I'm gonna go into the client folder, and this is a poetry project, so I'm gonna do poetry install. So poetry is just a wrapper around virtual env with kind of better, more fixed versioning across not just your direct dependencies, but also their dependencies and their dependencies, to give you a sort of more sort of safe and controlled environment. So that should take a minute. Okay. So the other thing I'm going to do is I'm going to find out where this virtual environment went. And I'm going to set that as my virtual environment here. So let's say I want another one that exists. Okay, So this is going to take a second to index, but that will give us nice highlighting and also completion. So while this happens, just to sort of quickly go through the actual SDK. So the main thing to note in here is we have a code gen folder, and what we have used to generate this SDK is a combination of libraries called Podite and Soulmate, and they're both mostly contributions from Jump Trading. So I guess Podite is a sort of plain old data kind of library, so like a C-struct equivalent, where the length and the sequence of your fields there, you know the offsets, and you can sort of very quickly go and read and write to any of them. And then Soulmate is kind of like the anchor client for Python. So it will parse your your lib file with your program and the functions and the accounts, and it will actually generate an interface for you. So both of these are open source projects. You can quickly find them by looking at GitHub. So we have now indexed everything, so we should be in good shape. So the next thing I'm going to do is I'm going to make a bot folder. And then I am going to copy, so a bot I wrote, and then I'm going to sort of go through it. I conveniently misspelled words before. Client, dexterity. So there we are. So I'm going to take this guy and copy it into dexterity. So here we are. Okay, so we are going to follow this step by step and actually run a few things and see what happens. So I guess a few things to sort of introduce first. So and a very important concept in Dexterity is that of the market product group. So a market product group is a collection of products. I believe it's 128 that can be there at any one time that are active. And these are products that we can cross margin. So you can have a position in all those products, and we will only require you to post the collateral necessary for the combined portfolio, which is one of the unique features of Dexterity so far in the DeFi tech sort of space. The other important thing that you need is a trader risk group. So that's a one-to-one sort of account correspondence from a trader to everything to do with the market product group. So a trader risk group will hold all my positions, my open orders, my risk collateral requirements, all of that for a single market product group. This has some of the sort of implications, like if things are not in the same market product group, you can't kind of commingle them risk-wise. Also, if you want for anonymity purposes or something like that to create multiple MPGs, TRGs, then those are not going to be sort of offset. They're not going to offset each other naturally. Okay, so as I said, there is 5 contracts involved. Dummy Oracle is really just a it's kind of not really needed. It's just the code asks for it. So we're just going to put it there. But before I do anything, there's a couple of things I want to change. So first of all, I want to go to this file, and I want to make sure that I enable Preflight checks. And the reason I want to do that is because I'll get much better error messages in case kind of something goes wrong here. And this is something I recommend everyone does in development. Okay. So we've now done that in both places. And the other thing we're going to do is we're just going to stop the kind of the code that is our environment from trying to read things we don't need. So the risk engines are a good example. Okay, and then I'm just going to say just default to none or even throw, because I am actually going to use the risk engine. Okay, and now I'm going to go back and I'm going to configure my environment. So we should just be able to just copy these and then create one of these and then go into the environment and paste everything in there. So these are the actual, this is our DevNet deployment. And, you know, if you need a copy of these, obviously we'll make this available and you can read out on Discord. Okay. So I'm just going to comment these things again. Okay, so what have we got here? So we have the public key of the MPG we have already created. We've configured our environment with the other 5 contracts plus the sort of the dummy oracle, it's pointing to you know, something I made up, which is that with a single different number. And we're gonna attempt to create a test trader. Now, obviously, to create a trader, you need to create a bunch of accounts, and to create a bunch of accounts, you need to pay. So I just made like a throwaway key on DevNet, and I airdropped it some SOL. But other than that, you know, everything is as you'd expect. So okay, so let's dive into the SDK a little bit. So both the Rust and the Python SDKs, they're based around the SDK context and then the SDK trader. The trader is, as you expect, kind of the specific functionality for the trader, and the context is kind of the wider stuff like creating a trader or cranking or doing things like that. Now, depending on what you're doing, what you're writing, you might not kind of need all parts of it. So the context has a little sort of constructor method, which is like a little factor method rather, which is just called connect, and you pass you pass the MPG you want to connect, a payer to pay for operations, and then there's just a little convenience around sort of not swallowing errors and instead raising directly. Now, we are going to generate a key pair for the trader. So this is the key pair that controls everything about the trader, can administer them, including making things like deposits and withdrawals. So it's important to sort of keep it private. Now, in this case, because it's a throwaway service, I'm just going to print it out and then use it in my bot. But obviously, this is kind of important to keep safe. The SDK provides some conveniences around sort of attaching global functionality, so you don't have to keep doing the plumbing. For example, you can add a signer for you know, with a name essentially. So what we're going to do here is first of all, from my throwaway wallet that I airdropped money to, we're going to transfer some SOL to the key pair controlling the trader, because that's then going to start paying for creating the various bits. Other things we want to do is create an associated token account for the Vault Mint. So this is what we've called UXTC on mainnet. On DevNet, you know, it's really just a dummy that we created on the fly. And hopefully everyone knows what associated token accounts are, but they give you the ability to control multiple token accounts for multiple token mints with a single key instead of having a key per token account, which will be a very good experience. So finally, we're just gonna send those instructions, and then by calling register trader, it's basically a factoring method for the trader object that we're gonna get back and just kind of print all the all the information that we then need to start trading. Any questions so far in the room or on the call? No? Okay. All right. So I'm just going to go ahead and run this. So let's do it. So this is, yeah, there's some debug print in there for the market product group. Okay, so let's see what we have. So this is the trader pub key. This is just the pub key for the private key we create on the fly. This is, the private key. Obviously, we wouldn't normally print this, but for the purposes of doing this exercise, we're going to use this. And this is the trader risk group that ended up being generated. This is the Vault Mint, which is just kind of useful as debug information. And this is the associated token account for this trader for this mint. So what I want to do now is, normally if this was the real market, you'd go and buy some USDC and you go and trade, but obviously this is fake. So we're gonna just mint from from the Vault Mint that we control. We're just gonna mint some tokens. So I'm gonna do that now. I'll take this command. Paste this here. So what we're saying is mint for the HYUV mint. I believe it's 100 million, and we're going to send it to the associated token account. So here, so let's take that. And go here and paste that. Okay. So now we have 100 million DevNet UXC, or however you want to call it. The other thing I'm going to do is I'm going to take the key pair. In fact, I'm going to copy all of this information so I don't go to a very safe place like gedit. Then I'm going to take the key pair. And if you kind of look up here in the actual sort of trade loop, excuse me, it's probably down. We're B58 decoding a private key, so that's what I'm going to do. This is a private key. Okay, okay. And then I'm going to take the trader risk group. And I'm going to put it in here. Okay, so I'm going to remove the line for creating test trader, and I'm going to enable the line to trade. And let's kind of go through the code. So we have the MPG, we have the TRG, we have money in our wallet. Now, obviously, you don't trade with the money in your wallet. You have to deposit the money to the exchange. So as a sort of optional first step, we are going to tell this method how much to deposit. So we start by decoding a private key, creating a key pair. We then connect again the SDK. This time the payer is the key pair instead of whoever it was before. We can now do some cool things like explore the data. So this is kind of pod and soulmate kicking in and giving us nice debuggable data structures that we can use. But you know, the nice thing is you didn't have to really declare them anywhere. It just kind of all, you know, magically gets generated. And we're going to connect our trader. We're going to make a deposit to the exchange, and then we're going to go into a loop. Okay, and what can we sort of do as a minimum here? So the first thing we can do with the trader Sdk is we can cancel our all our orders, and you know, feel free to sort of dive into that. But basically, that, you know, parses the MPG, finds all the order IDs, and issues individual cancel instructions. That, yes, create, you know, what is essentially a usual normal instruction to send to the exchange. You know, if you want, you can obviously sort of try and bulk them into multiple, into a single transaction, etc. From there, we're just gonna go and get a snapshot of the market data, and I just wanted to put a little example in here of just using PIF. While this is not kind of directly tied to the Dexterity SDK, obviously we use PIF for settlement, and you know, it probably makes sense to use PIF as a reference price in your bots. So there's some simple logic in here that uses the, you know, the published Python client, which is on piping, to get prices. And then what we're going to do is we're going to look inside the product. We're going to find out when it expires, given it's a future. We're going to calculate like a forward price, and then we're going to add the spread around it, and we're going to place some orders. Now, the first time we place the order, but you know, the next time we, you know, we've chosen to replace, and the, you know, this is kind of a unique selling point of building on chain. You can, you know, do atomic things. You can, you know, can place and cancel, and if something goes wrong in either step, nothing's going to happen. So you just achieve that by creating a normal cancel and a normal place and just putting them in a single transaction. Now, an important thing to note is, and I'm just going to go back into place. So I believe while the mechanism for setting return values between CPI calls on chain is now released, there's no way to return a value to an RPC call. So if I'm sending an instruction, even if I sit there and I wait for it to be confirmed, there's no way for data to come back. And I believe I saw a proposal on the Solana website, but I'm not sure if it's happening or if it's out. I don't believe it's actually out at the moment. So to get your order IDs, what we're doing for the time being is we're reading the logs. And this is kind of something that we've all agreed collectively is a reasonable solution for the time being. And this is just a limitation, I guess, that we have to work with. So we quickly scrape the logs. If we find something that looks like what we know is the order summary line, then we get the ID out. Otherwise, we you know, assume that the order was not placed. So that is really what this code does. And as I said, Jerry's going to go a lot deeper into writing bots and you know, a lot more sophisticated strategies around that. But the last thing I want to say is there's another sort of byproduct of just how, you know, how Solana works. So Solana needs you to pass in every input and every output account that's going to get used. So everything you're going to read and everything you're going to write to needs to be an input to your instruction. Now, that essentially has the side effect of leaking implementation details into, you know, the interface, basically. So you can't just say place. You have to say place. And by the way, here's all the things the risk engine is going to need to read. So we have a little utility method called get risk accounts, which you don't have to really sort of understand. There's two accounts that we call SNR, and they contain some information particular to your trader to let the risk engine do its job. And obviously the risk engine then kind of ensures that, you know, you are who you say you are, and the accounts are the ones they should be. And then we can just send the orders. So that's really as simple as that. So in, you know, 200 lines of code, you can, you know, deposit to an exchange and start trading derivatives, and you know, that's a pretty impressive feat, and you don't have to go through you know, all the middlemen and all the kind of levels of interaction you would in a centralized exchange. So as a last step, I am going to run this. So let's give it a go. So this is printing the balance before my deposit, but then it went and deposited 100,000. So now you can see I canceled all my orders. I didn't actually have any. And then we placed an ask and a bid for you know, some prices we calculated around the around the mid from pith, and then I did the, you know, calculated forward. By the way, we're just taking the first instrument, whichever that happens to be. So we're not doing all 8 instruments or all 9 instruments that we have going at any one time, which is weeklies, monthlies, quarterlies, and perp. And so this is basically now going around the loop, replacing its order, doing its thing. Now, obviously, you know, if there are other participants in the market, you're going to end up trading with them, and then there's a lot to be said about you know, your risk management, how to get your risk information. It's out of scope for today, but these are things that, you know, are very much kind of ready and working, and you can't you know, you can't kind of trade to your heart's content. You have to always be within your risk checks. Okay, so this is, you know, this will happily tag along for a while, so I'm just going to stop it for now. I did add a signal handler, but it doesn't seem to be behaving very well. So I'm just going to kill it. Okay, let's go back to for some reason my browser doesn't. Okay, so as I said before, you know, Dexterity is not a product, it's not just a market, it's a set of primitives that, you know, we envisage being used for a number of things as the kind of the base layer, the you know, the aggregate liquidity. So some kind of ongoing cooperations we have are with things like option vaults. We are working with market makers to onboard and provide liquidity to the markets. The community is building a UI, and we've in fact kind of recently had more interest on this, just building sort of better trading interfaces. And something we're very excited about is using Dexterity and the risk engine Spandex for risk management, for kind of OTC trades, you know, RFQ protocols. So not necessarily even going through the order book, and we actually have an ongoing build happening on that right now. This is an example of one of the features that's actually in the closed domain at the moment, and you can't access using the open source Dexterity SDK. But again, as things evolve, we're going to sort of decide as a community where to go. So just a bit more sort of specifically on the SDK. So you know, we've just kind of gone through the Python SDK. You know, in that other folder that I showed you was the Rust SDK. We've tried to keep them very similar. The Rust SDK is kind of by default very well documented because all our tests use it. So if you want to see how to do that, you can just go into the Dex test folder and kind of see it in you know, being used in practice, and then most of it should transfer. All of it will transfer to the Python SDK. There might be sort of little differences that you have to understand, just because the languages are kind of different. We are working on a TypeScript SDK. This is something we've developed alongside the community, building the UI. That's again not in the that's not open source yet. However, it will be on an NPM package, so it's as good as and it will be usable by everyone. If you want to compose with us, and you can use the open source project, which is the majority of things apart from printing trades. You can again just use the instructions as they are. We are working on a better sort of on an automated way to produce the complete instruction set automatically on every release that we do. So that's kind of coming soon. Yeah, and then finally, we have a website. The documentation page is kind of increasingly being populated with a lot of good material. Obviously, things like all the white papers, the liquidity protocols, all the ideas around staking, and then sort of the utility of the token governance are all on there. And yeah, you can always find us on social media, on Discord. The developers are there, as well as the founders and everyone else, happy to help. And on Twitter. And that's really all I have today. Anyone?
That was great. Thanks, Kostas. Yeah. Anybody have questions?
So the question was, what are your... Yeah. Mm-hmm. Okay, so this is a deployment on DevNet of 5 smart contracts that are working together to create this market. So the order book is the agnostic order book that is an adaptation of Serum that we have deployed our own instance of, and then Dexterity, the Dex kind of builds on top and uses it just as an AOP to add all the risk checks and everything else on top of that. But it's all on chain. With this bot, I mean, the whole SDK is for Dexterity. Normally, what you probably see in a trading firm is you'll have like an order management system sitting between the trading strategy, speaking some internal protocol, and then the order management system might have a smart order router that then talks to both centralized and decentralized exchanges potentially, and then pulls an aggregated order book and shows it to you. Obviously, you know, the latencies are very different, orders of magnitude different, so obviously you have to sort of take into account where you're trading. But it's perfectly possible to use both at the same time.
Hello everyone. I'm Tom. I'm a developer at Hxro as well.
Okay, so we're gonna make this recording available.
I think Tom was speaking.
Oh, he was?
Yeah.
Yeah. Can you hear me, Kostas? I just wanted to chime in and make sure that we repeat the questions on the stream so that we can all hear what the question was.
Yeah, Kostas, what was Alejandra's question?
Oh, yeah, sorry. So the first question was where is the exchange essentially, and the second question was whether we can take this bot and plug it into a different source of liquidity, which kind of is why we discussed the prospect of having an order management system in the middle.
Got it. Anything else you want to add?
Nothing else specific. I'm open to questions as well if anyone has questions.
Great. I think we're good. All right. So thank you for everyone attending, and thank you, Kostas, for that detailed tutorial. And we're going to be hosting workshops here in Chicago, Solana Summer Hackathon, Hacker House, every Tuesday and Thursday. So the next one's going to be Thursday. Jerry Zhao, who's a Solana core engineer and contributor, and one of the contributors to Dexterity Protocol, is going to be doing the next workshop on building trading strategies to Hxro Dexterity. And then in terms of schedule, next week On Tuesday, Jordan Prince is going to cover Cupcake Protocol. Thursday, Nick Fazzari, who is a Hxro core contributor and one of the builders of Spandex Risk Engine, is going to do a crash course on derivatives, a general course on derivatives. And then the following week, Tuesday, August 9th, Armani Ferrante is going to demo Backpack. And then August 11th, we're going to host a demo day. So that's the schedule. Thank you for everybody who participated today, and look forward to seeing you at the other workshops.
Thank you.
Thanks, everyone.